A few of these names are Dr. John Mack, Dr. Angela Thompson, Dr. Scott Mandliker, Dr. Nick Begich, Dr. L. Joe Hasselhoff, Dr. Stephen Greer, Dr. Ted Loader, Dr. James McKinney, Dr. Roger Lear, Dr. Claude Swanson. I'm sure that I forgot some people. I apologize for that. But these are just a few of the names, guys. Think about it. Hard scientists, doctors that have come forward to speak and to tell us more truth about the subjects for which we're all looking for answers. Now we welcome Dr. Norman Bergrun. Now, you only have just like a thumbnail sketch of his scientific and academic achievement in your program. Guys, it's as long as both arms and both legs. It is. And yet, think about this. Dr. Norman Bergrun, we're welcoming him here today, but it's been almost 20 years ago that he published his book, The Rings of Saturn. 20 years ago, this great credentialed man of science actually risked everything to come forward to tell us some truth. 20 years ago almost. He was a pioneer, a great man. Ladies and gentlemen, please give your warmest possible welcome to Dr. Norman Bergrun.
Thanks, Bob, for that wonderful introduction. And I have a little memento here that depicts how far we've come in 100 years. And you'll see how far some other people have already come in my presentation. So this is sort of a memento of aerospace.
Uh-oh. Norman, thank you. Thank you so much. I will treasure this memento. Thank you.
You're welcome. Are you ready for all of this now? Okay. I'm going to sort of brief you on what you might expect during the presentation so you have a feel of where this thing is going and so that you're not taken back completely by surprise during the presentation. Now the title of ET Intelligence, and I added a tagline that says the open secret. Well, I'm going to show you some vehicles. Now, vehicles is a generic term, and it can be applied to biotic kinds of things, or it can indeed apply to a craft. For example, you're a vehicle for something, and so that's what I mean by that term being very generic. Now I'm going to show you first a couple of vehicles that owe to my own personal sighting, and then some other instances will be cited using NASA images. And then I'm going to point out technological characteristics that of these vehicles that will be developed. They're advanced. Now this advanced technology is what gives the inference of intelligence in the high IQ range. Now, there are some events that occurred on the moon and around the moon, and these will be shown for Apollos 12, 13, and 14. And the open secret pertains to NASA images and data being open to the public. For example, Voyager and Hubble and other missions, they're available to the public on the web, but not enough images to disclose much of anything. You can't work with those images. And thereby, we've got a secret that is open. It's a secret staring you in the face, but there's no closure to it. Well, like some others that appeared before me, we're trying to get closure on that. Now, I'm supposed to have a slide thing here. Now that's my first slide that sets up a calibrate. Okay, now there's the title slide, and I've explained about the title, so we can move on. I don't know what happened to that one. There should be another one before that. Okay, well, I'll tell you a story about this airplane. It's an Orion P-3 airplane, and its gross weight is 127,500 pounds. It can carry 60,000 gallons of fuel, and it can carry well of a load of armament, like 10 torpedoes, depth charges of all types, and being a submarine hunter airplane, why, they've got all kinds of other equipment on board. They have redundant equipment for safety. It's an airplane that has lived through a long period of time, and even today, its upgrade model is still flying, and so that gives you an idea of an airplane that has lived a long life. Now, this airplane vanished off the California coast near Point Sur with 8 crew members aboard, and the date was May 27th, 1972. The last radio contact was over what was then known as the Salinas radio beacon, and this beacon is located on the coast and practically directly west of the town of Salinas. Now, if anyone would like to see the full content of the news clip, why see me afterwards when we're at the book table. Now, I've told you about some of the characteristics. It has 4,300 horsepower engines. And so when you add the torpedoes, the 13 depth bombs, the different sizes, 6 mines, 3 1,000 pounders and 3 2,000 pounders, you got a lot of equipment that was lost off of Point Sur. The commanding officer of the day for the squadron was actually, according to the press article, just befuddled because he could not imagine how an airplane like that could vanish, literally vanish. There was no oil trace in the search. They really scoured things, and they came up with nothing. So this airplane just really disappeared, along with the people aboard. I will tell you a little bit more about that in conjunction with some things that happened on Monterey Bay. Now, the Point Sur is located slightly south of the Monterey Bay area, and is about halfway. Now, that's a very dim slide, so you have to tune that up. There we go. You see Monterey Bay there, and get out a pointer. Okay, Pajara Dunes is about halfway down here, and Santa Cruz is up in here, and Monterey, of course, is down there in this corner right there. Monterey is down at the bottom corner, and Pajara Dunes, which is labeled, you can see quite clearly. Okay, so in September of 1971, I was at Pajara Dunes. We had spent a week vacation there, and this was the last day, full day that we were going to be there. And I was laying flat on my back at Pahara Dunes, looking up this way. And when I did that, why, I saw a bright, very bright light, intense light. And I thought at first it was a huge Navy helicopter crossing the bay. I'd seen those before, and I thought surely that was it. And the sun had been over my back, and so it was shining towards what would have been the windscreen of the airplane. But after a while, it became evident that no windscreen could produce the reflections that I was beginning to see. And so at this juncture, I ran and got a binocular and took a sighting on it. And what I found was, we have here a model. Can you see that? The thing that I saw was a silvery vehicle that was long. Its diameter was maybe about 1/13 of its length. It had azure blue flames at each end, and it kept going through capabilities that it had. What happened next was that two flames, rod-like flames, shot out, indicated by these two elements. And then between those two elements was a black rod kind of thing. And when it reached the end of where the flame-like pair were, a huge, intense light was formed, like an arc light. Now, you probably are wondering what these are. First, let me tell you that underneath the nose there was flame-like characteristics too. I call that part a mustache for the vehicle. Now, the streamers, there were pairs of streamers, one from each side would come up and coalesce together. And there were a number of these, and I've shown 3 here with the model. The streamers were pinched plasma. That is, there's a ball of plasma that would come out. Plasma, there is 4 states of matter: solid, liquid, and gas, and plasma. And that means that it's gas at high temperature. So it would belch out a globule of plasma, and it would pinch down, and then another globule would move up. And so these globules would just move along here with a successive one being coming out from the vehicle. Okay, so that was the case. The interesting thing about these streamers were that they were a sickening chartreuse, that is a yellow-green. And that means that there was chlorine in that streamer. And this would be enough to upset our ozone layer, is to get some of that chlorine there. That's an easy way to do it. Okay, so I realized as the aft end was being covered over with a cloud-like character that I best go and try to take a picture before I lost all the picture over its full length. And that I did, and I was successful in getting one picture that while it's all clouded up from here to about in here, still you can tell that there is a body in there, and you're going to see that. It took me a long while to figure that out, but because it was so hard to get out of the film that I had. There is a quick pictorial of this model that I drew very soon after I got home, just to record basically how it looked. It may not be exact proportion, but it does show the characteristics that were there. And Those streamers look a little bit more chartreusey. Now, this element here, I wanted to draw to your attention because a streamer looked more like that in being pinched plasma. It's more sinusoidal and more harmonious to the eye. Now that drawing there for the body, it rests in there. If this is the nose, then as you see it, the aft end is farther behind the picture than the front end. So you can't quite see the nose completely as an ellipse, but those kinds of details are what tell you how a body is viewed with respect to your eyesight. Okay. Now here is my picture from our condo deck. Our deck was like that deck, and I had my camera resting on the rail, like one of these rails. And I was shooting towards Santa Cruz, as you can see, and you can see that everything is all clouded up here. You see a dark spot, which indicates something's there, and so on. I don't know whether you can see a 1 here and a 1 down here, but that's where the body is located. And then there's a projection from the body, which is labeled 2. Now, this is a blow-up, which makes it more clear that there was a body right in here. This curve says that this thing is rounded, and here is the cloud structure that's there. And the body's labeled 1 between these two 1s. And then there's a projection here.
Excuse me.
Yes.
When you face the screen, we can't hear you because you're not speaking into the mic.
Okay.
Right into that mic.
Okay. There is a projection from the side here, and that's labeled 2. You can see some rising elements up here for 3, and they're fairly substantial, and so you can get some indication of what's making the clouding effect. Now, there was in December, as I recall, I made a sighting from my place at a high point from Los Altos Hills. And this had been going on for some time, and I finally got off my duff and photographed this object. It had shown itself as a multicolored glimmering light, and I finally decided, hey, we've got to know more about that thing. And at the top here is a streamer, and right in here is the end, and here is some cloud-like structure, and here is the other end in here. And you can see it has some color to it, and it's not just white, but all of that twinkles. And so when you look up in the sky, if you see something that's intensely bright and it twinkles different colors, and you see some streamers popping out, like I showed you, that's not an airplane because it shoots out these streamers in all directions. And so you get more interest that way in what you're looking at and understand it. Now, I want to know where this vehicle was geometrically, and okay, they've got the picture tuned up here so that you can see that we did a sighting from Los Altos Hills, and I was down in Santa Cruz, and my wife was in Los Altos Hills, and she made a bearing fix on the thing, and at agreed time, I made my sighting on the Santa Cruz beach. And what you see there is two lines that intersect. And they intersect about 60 miles off of the coast and about 65 statute miles away from Point Sur, which is lower down. Now, I'm going to mention the loss of the Akron or the Macon Graf Zeppelin, and it is a Zeppelin. It's not a Graf Zeppelin, but it's from the German design, Zeppelin. I knew Colonel Walter Gaspar, who was the officer of the day at the time the Macon went down. And I remember his saying, well, it went down off of Point Sur. And I thought, well, gee, that's interesting. And so during the preparation for this talk, I searched around, and I found, lo and behold, the coordinates of where it went down. And as a matter of fact, having those coordinates, the historical department of the Lakehurst Naval Station wrote me and asked me, what coordinates did you find out? Because they would like to record that. So, yeah, it was a little work to do that, but it was a lot of fun. Now, if that could be lightened up so people could see it better, but that is the Macon ship, and it went down off of Point Sur, and its coordinates are just a degree away in terms of latitude, and only a few minutes away in terms of let's see, 1 degree away in terms of longitude, and just minutes away in terms of latitude. And this thing carried 83 people, lots of gear. It's capable of carrying airplanes. It's a warship, and it went down in practically the location where we made our sighting. Now, the Orion airplane went down in the same area. So here we have a couple of warships that have gone down off of Point Sur. And I think the characteristic, the fact that there were capabilities, this thing could carry 4 airplanes, it begins to tell us something about what we can expect in terms of attitude from our extraterrestrial friends that obviously are out there. So, well, that's my own opinion. Maybe you won't disagree with me. I'm part of all of you trying to put pieces of a puzzle together, and I don't mean to try to belittle that in any way. It's another piece of the puzzle. Okay, now we're going to move on to talking about Saturn. And if that could be brightened up, it's going the wrong way. The thing about this chart is that it shows that between the encounter that Voyager 1 had on the date that's given there, 12 November, and then Voyager 2 came along, there's only 9 months difference in the time that these 2 missions were conducted. Now, the party line, and I use party line as what NASA says, this is what we're going to tell the public. And they stick to a party line for a while, and then when they see that's not going to work, why they come up with another party line. Much the same as they do in politics. The story was at the time that rings were made of primordial matter. The rings were essentially static, and that there was no material in the Cassini division. Well, when I took notes of Voyager 1 encounter live on TV, and I had about a stack 1/4 inch thick of notes, and then Voyager 2 came along, lo and behold, there was stuff in the Cassini division, and that was sort of a no-no. That was not expected. So So now they've changed the party line to say it's broken up moons and big ice chunks out there and so forth. Excuse me. Now, going on, I want to familiarize you with the names of the rings. Way out of the tip there is an A ring, or an F ring, and you move in. That's a real tiny, insignificant ring. Then you move into the A ring, and then the A ring has a division in it called the Encke division. So, in that Encke division moves like from 25% away from the outer edge to about 25% away from the inner edge. So that Encke division can move around. Now, going on towards the B ring, before you get to the B ring, you find the Cassini division. And there is pictured with some material in it. Then there is the entire B ring, and right beside it, the C ring, and beside that, the D ring. By and large, we'll be dealing only with the A ring. There's the front cover of my book. The orange spot that you see there will come for discussion a little later on. But this is a spot of energy that's adjacent to the left side of the A ring. Okay, now that slide is intentionally dark because that's the way it was made in the first place. It's a little too dark here, though. Yeah, there we go. Now, in looking at this dark slide, what I noticed was that I could follow the ring around on the top side, but down at the bottom, I was unable to do it. You see, the rings are labeled here. Now, there's a luminous source here, and that's the luminous source I pointed out that's on the front cover of the book. It's on the left side. Excuse me. Now, I've labeled 1 and 2 here, and we'll discuss these things in order. And you'll find that down here it was impossible to find the ring because it was not there. This is a depiction of the situation, and this is sort of a picture of size. The various rings are labeled on the left, and you see that 10 Earth diameters approximately, or the diameter of Saturn, and that the total width of the ring system on one side is like 6 Earth diameters long. So that makes a total width of the system 22 Earth diameters, and that's a well of a large distance. Now, the other thing about this picture is that when the ring is cut off across the Cassini division there, you get a large length for whatever is across there. And that I have 2 vertical lines coming down, and so for that much of the ring is shown there, that's 2.5 Earth diameters. So you begin to get a feel for the length of an object that might be there. Now, there we go. You see, I've labeled the B ring, and this luminous source, that's the one on the left, and it's the one on the book cover. And that thing is larger in diameter than our moon. So that's a big chunk of energy to be sitting out there besides the ring. Now, when I first discovered that the ring was cut off, I was actually mystified. Excuse me. The mystery came from realizing that the ring was incomplete circularly. But it dawned on me that, hey, this ring is not there radially either, because typically the ring width for the A ring should be something like four times the width of the Cassini division. And here we find that we're lucky if we get maybe 2, something of that nature. Well, that helped a lot, because now all of the A ring is not there, in addition to the ring not being completely circular. And so that something is going on. Okay, great. Yeah. No. All right, they got me lined up so that when I talk about these pictures, that it sounds much better, okay? So we got to thank our staff here. They're really right on the ball. I've been impressed with all their capabilities. Now, this long object that's in here is what terminates the ring. And when you examine it more in detail, you find that there's a little exhaust there and a little down in here. And here's a light source below it. And then there are some streamers that form here, these white things I call the streamers, and they go up into the ring. And you can see that there's a body of some sort there. And so, whoa, now I understand how the rings are made, inasmuch as there is nothing in the way of a ring beyond the end of the cylindrical body. And that nails it down, that there's nothing further out other than what you see portrayed by the length of the body. Now, what I tried to do later on was to identify characteristics to say, well, what kind of body? And that turned out to be electrical. And so now you have a heads-up view of how that's going. Now, this slide I have presented because there has been a gent that has made up a story about this figure here, which I just showed you, that he did not believe that what I had was the right picture, but he submitted that this one was correct. Well, I've put some numbers up here. The first one here is one that says there's a light below the nose. You see, there's no light below this nose, and that wipes him out right there. Here is texture of the A-ring. The texture of that looks different than this. And so he's off base on that. They don't look right in the rings. And for this one, there's a little streamer up in here. It's very hard to see in this image. But this one has a big, broad image coming here. And you can see some of these pinch plasma things going up there. So in addition, this one has some blue appearance down here. The other one does not. So the fellow was really off base. And the reason he got off base was that he did not understand that there's several levels of data processing. He had the 0 level of data processing. He had raw information. That raw information is corrected to level 1, and then there's level 2 that has only pictures that are designed for land, where you take a look at a picture and adjust it so it lines up with longitudinal lines and that kind of thing. So he mistook himself with regard to the characteristic of the images. Now, he asserted that there were 4 images that were stacked on top of one another to create the colored image that you see there for my picture. Well, it turns out that when you get the process data, why there are extensions on the rings that if you lined them up for color purposes, these things would stick out and you would know it. And that's the other thing that I pointed out. And so his case fails miserably. And so I present this here because he's been all over the net with it, but he's just a book salesman, and he really doesn't have the talent to know what he's doing. Okay, now we're going to the other side, and most everything's labeled there for you that you can see. You're acquainted now with the A ring and the B ring, the Cassidy division, and that luminous source. Now here, the luminous source doesn't look orange because this image is one that is highly exposed in order to bring out these various features. But you can see a little bit of exhaust there for the longitudinal object, and you can see body emissions that go up into the ring. And the thing I wanted to talk to you about was that there is a toroid on a curved arm that goes up from down in here. And around a conductor carrying electricity, you could have material gather as a toroid. And that's because of the way the magnetic field exists around the conductor. Now, this is supposed to be an example of a conductor. It's a little blanked out. It's a little overexposed. There we go. There we go. I've taken a plane just across the conductor at right angles and given you the direction of the current flow. And under that setup, you get a concentric magnetic field around that conductor. And so you can think of that plane as being one element of a toroid, which is really a donut-shaped object. And so a number of little spaces to each side of this would contribute to making a donut shape or a toroid. And a number of those can be made all along the conductor. So now you're beginning to see that it has some electromagnetic characteristics. Okay, we're back to this, and why we are going back to this is that you see these streamers come up in here. Well, there's other action in here, and you can vaguely see it right here that go back. When streamers cross each other at right angles, you know darn well that there is an electrical field there. And I drew this to bring out that idea that I saw in those rings, so it's clear as to what I'm talking about. The streamers come up from down below and like that, and then there's some streamers on the body that flow aft, and they intersect essentially at right angles, and that tells you that that field is an electrical field. Otherwise, they would not intersect at right angles. So now you begin to see it's electromagnetic in character. And just from these 2 points, I feel that we can name these vehicles EMVs, electromagnetic vehicles, because it does describe essentially the characteristics that they possess. I said the title of the slide there is orthogonality of the streamers. Well, that word means perpendicularity, so it's the same thing. Now here is a flow field around a cylinder. Now what I want you to do is to envision that on the top side here there's a plate, and you have a battery, and this is a positive side, and down at the bottom there's a plate, and that's the negative side. Okay, and you have a circle in a medium here that would enable current to flow from here to here. All right, what happens is these what you recognize as streamlines around the circle can be viewed as potential lines. And the reason they're electrical potential lines is because they're lining up with this plate up here that's at some value, and one line is actually a straight line. And it gets closer to this way, it takes on the curvature of this. And the same way on the opposite side of the axis. Now, you also know that current is flowing from the top here to the bottom. And so those current lines will be perpendicular everywhere on their trip to the other side. And that demonstrates a perpendicularity of flow that represents electromagnetic characteristic. Now, what happened at Voyager 2 when it passed the rings of Saturn? It's interesting in that we had aboard a plasma probe ring detector, so that we're examining plasma in the ring, and so that heretofore nobody has acknowledged that the rings contain plasma. Well, here's a little graph that I'll show what the ring thickness is for this particular thing. Now, mind you, ring thickness is thought of as being only about 10 miles thick. That is what is being toted right now. It's 10 miles or less. And yes, the rings can get that thin, but they can also be quite thick depending upon how close to one of these EMVs that the measurement is taken by, because they are thick, and so the stuff that came out will be thick in that locality. All right, now going on here, this curve is the path of Voyager 2 past the ring. Now, in a very short interval here, the instrument is working away, and it's creating a time history of what it sees in the way of plasma. Now, the instrument works with different frequencies, so it can sense plasma in different frequencies. And the way it's recorded is in decibels. So when you get some blips here, why, that's the measurement. So nothing will happen for a while, and then all of a sudden you get a blip across here, and that trace will continue. The same way all along here, you see it's time between here and here, and there are these little spreads all along here. Now you can calculate the thickness of the ring by distance equals velocity times time. And you do know the velocity of the spacecraft, and you know the time because it's recorded. And so what you do is to take the little difference in time represented by a spread of one of these little normal distribution kinds of curves in there, and that will give you the ring thickness. Now, you notice that on the left side, the length of those rises is greater than on the top side. Here it looks like very little. So this means that you're going to get a spread in the numbers that you assert are the thickness of the ring, and indeed you do. I got 435 to over 600 miles for that. Okay, that is a large distance. And this is the only sample that I know of that says that you can have really thick rings. And the reason is that there's an object in there, and this time they measured one fairly close to the object and got a fairly large number for thickness. Now, if it had been measured at another point, say well aft of a body that was in there, they wouldn't have seen a thick ring at all. It would have been like a contrail from an airplane. It would have faded off, and they would have got a much less value for the ring thickness. So when you talk to people about ring thickness, you can say, well, it can vary all over the place. Now, here is an interesting picture, at least to me. Before I published Ringmakers of Saturn, I went through astronomy literature to see if I couldn't find something that was similar to what I had, if that was all possible. And this is the one that seemed most appropriate. Here is a picture of Saturn, and it's labeled Passage of a Star. There were two astronomers, Knight and Ainslie, in Great Britain, and they were both astronomers but working at different laboratories. And Knight spotted what he called a star, in as much as it was very intensely lit, passing through the ring of Saturn. And you see that the path it's on is also the same path where we found the clipped ring for Saturn in what I've showed you before. So this is why it struck me as being a very applicable kind of thing. And Knight followed that along into the Cassini division, and that's about where Ainslie picked it up, because it was such a clear spot to be in. He could see it, and both gents, when they got together afterwards, composed the composite picture there. You see that it was on a straight line course going through the Cassini division and out. Now, Knight said that, gee, this thing really ate its way right through the ring with no problem. And he was really amazed. And as a matter of fact, this is one of the famous, you might say, accomplishments of the time. It was felt that it was proven by this that there was nothing in the A-ring. Well, that may have been true once, but that's no longer true, as you know, because we see stuff in the Cassini division. Now we're going to take you out to Miranda, which is it's a satellite of Uranus. You've lost me on this one. Doesn't look like. It needs to be lightened up a little bit. Okay. This looks completely different from anything I have seen in this picture. But anyway, we'll go through it. My original thought was that this object right here was a part of a continuous object that goes through here. Actually, what it looks like, the object is here and goes way down through here. So I have to change my mind about the way this picture looks. But nevertheless, this looks like a short EMV right through here. and there's a streamer that rises right up there, and then there's this would be the end. You can see it's sort of circular in character, and it has a protrusion down below it, and that is characteristic of the kind of thing that I saw at Pahara Dunes. And then there is projection material out here, and that too is characteristic of one of these EMVs. Now it looks like that in fact there are, in the way they got them blown up here, that there is another object right in here, and that it has a lateral protrusion way out here, and there is emission from it. The thing that I think is so significant about this picture is that these elements right down here at the bottom, they're thin little things labeled 8 and 9. I call them energy rolls because obviously these EMVs can use something and they carry along with them so that they can make any kind of form that they want. And so to me, these elements along here are stores, such as like a fighter airplane carries torpedoes and so forth. They call that stores. And now, with those in position there, you see they've controlled all the emissions that have come out of that area. They've done it deliberately, and underneath there, why they probably have something that we'd like to know about. So it shows that they're capable of managing their image look. And now that they're electromagnetic, that means that they can do this to make any shape they want, an infinite number of shapes. And so what you find is that in being an infinite number of shapes, you think you're seeing things that are different from time to time. Well, in a way that is true, but it's all coming from one kind of unit, and it just has varying things that it can do, and so these varying things can look different, so that you lose the significant idea that there is one basic thing that's showing all these peculiar things. Now, how are Ringmakers as UFOs? Well, the answer to that question is they make darn good UFOs. At the top of the picture to the left, now first let me say the little black bar wherever it appears is just a simple representation of an EMV. Now, on the top to the left, why it shows a hump on the top and the bottom. To the right of that, why that hump and what's around there, it could make it look like a hat. And the central picture would be a cross-section of that, and it would look that way. Now, they can have emissions that are not circular. They can shape them so it looks like that. But they also can make any number of different appearances, so it could be square for that matter. Now you go down to the lower left corner and you see an L-shaped object. You have an EMV projecting only to the right, and so you get an L shape. And as a matter of fact, I've seen an account of an L shape, and that's how you do it. You could have the projection on the other side, so it looks different. Okay, and so on the right lower hand corner, you have a lenticular cloud-like formation, and you have the EMV in it. That's a typical kind of thing that they can pull. And you see a lenticular cloud, quite possibly there's an EMV in there. So you can see that they have qualities that make them candidates for making UFOs. But we've got to get into the mode of IFOs, where we identify things And this begins to bring things to closure and understanding. So the EMV is a long cylindrical object now. It's electromagnetic in character, and we should be referring to that as an IFO. Now they have stuff that they give off, and we should begin now to label the stuff they give off. And we'd only know if we can find the EMV at the time and begin to piece all this stuff together. It'd be a fascinating thing to find all the capabilities. Here is a cover that of a report that was put out by the UNESCO under the auspices of the National da Vinci in Rome. The reason why I show that is that I was at Rome where they put on a congress and they wanted to have something on the nature of impact of science on culture, and that's the charter of UNESCO. So I chose the idea that weather was a common thing, and I had already decided that our weather could be messed up with the presence of these things because of these plasma streamers and so forth. And I showed the pictures essentially that I've showed you and said, well, now weather is not going to be what it used to be. And that certainly has been the case. This was 1987, and I'm very proud that what I said there has come true. So there is a lot of truth in this, in as much as I've seen this happen over a period of quite a few years now. And so I want to tie those things together. Now, I've been warned about bringing up global warming debate heats up and record artists. Well, the thought here is that this is the way things are going to go with EMVs being present. I'm not trying to step on anybody's toes here with regard to environment or anything like that, but all I'm trying to say in putting the pieces of this puzzle together, we have a new variable that's not being considered. And the variable is these EMVs. And they have prodigious energy, as I showed you from that one luminous source that's larger than the diameter of our moon. And so it could also cause the ice to melt and so forth. So that's the only kind of thing that I wanted to get across on that. Now we're going to go to Apollo 12, and Pete Conrad was the chief domo in that flight, and Gordon stuck with the orbiting spacecraft, and Bean went along with Gordon. Okay, this is supposed to be Pete. No, it's supposed to be Bean out there on what I've labeled item 1. And the item 2 is a solar wind collector that is supposed to be there. The solar wind collector has a little flag-like kind of thing that you don't see in this view, but so that the cosmic particles can hit it. Okay, so this is advertised on the net by Eric Jones, who is the author of the article. Well, there's Bean out there, and he looks like he's taking a picture of us. That little white spot looks like a camera to him, and it does look like an astronaut. It looks like there's legs here, and but let's go take a closer look at that. Well, he's moved here in this the same kind of thing. It looks like he's turned around, and maybe he's going to shoot a picture over to the left. Now we'll take a picture of there. That's the first one. You see, it's not an astronaut at all. It's some sort of a body. Item 1 points to a body kind of thing. And the only thing that made you think that it was an astronaut was all this shading with light here. And there's the little camera blurb that now they thought, well, he's taking a camera. But when you look up close at the leg, hey, this is not an astronaut dress suit at all. It's some sort of object. Okay, here is the second view. And I don't know whether the light could contrast this arm out here or not, but there is an arm out here, and it looks like a head sort of thing. And it's only this lighting effect that makes you believe from a distance that there is an astronaut out there. But that is not an astronaut. That is not Bean. No way. The fact that there is an arm out this way makes the thing look biotically like a robot. I don't know what. Okay. Now, this is supposed to be Pete Conrad. You know, the commanding officer always puts up the flag. And so the thought of Greg Jones was, and of course, that is Pete Conrad there. He's fixing the flag like all commanders do when they land on Apollo. Now, I've drawn in 2 arrows that are split. I just labeled them 1 because I want to focus your attention to the area between those 2 arrowheads. And what I'm going to do is to present the next picture where you can tell where the tip of the flag is, and then we work down lower from there, just to keep you with the picture. No, that is not that's not the right picture. We're going all the way down. The one that I told you was there, it was changed color to the point of it not being recognizable. This is on Pete, so-called Pete, abdomen on the left side. And arrow 1 points to an edge of sort of a crater-like object in that dark area. That dark area 2 is well, first the 2 is a protrusion out of the dark area, which is sort of like a cavity. And then the 3 points to some material that goes down to the ground or the surface of the moon. And so this growth that you see here is a huge thing. It goes to the moon. You can see how it goes up north up here. If that's Pete, he didn't live. But we know that he came back. And so, again, we have a situation where we thought we saw an astronaut, but it was not an astronaut. It was something else. Okay, and then we go to the lunar modules on the moon, and I'm going to show you 3 of these. Now the get times, I don't know where you can read them. I can't read them from here. But anyway, there's a question about whether the pictures are in the right order for the progressing get times. Get means a ground elapsed time. That is, since they blasted off, that's how many hours, minutes, and seconds that they have been away from the ground. Okay, now you see the limb on the horizon, and it sort of looks like the limb. And 3 points it out again, but in the foreground, down here low is the color calibrator for color processing the pictures, and it's called the NOMI. And then there's the mobile transporter, which is sort of like a wheelbarrow on this flight, on this mission to carry stuff around. It was a sort of an awkward thing. But anyway, our interest is out there on the horizon. And here's another shot out there on the horizon. And item 2, again, is the color calibrator, the NOMI. Now, they've cut off the top part of this. If they could lower that picture, it's way off. Because what I'm going to show you is, no, it's going the wrong way. There we go. Okay, this is the lander on Apollo 11. And what I wanted you to notice is that this octagon shape lies a long way above the ground. Okay? And then we're going to compare that visual memory with this. Now, this is the first picture I showed you out there in the horizon for the LEM. We do see an octagon shape here, so that should be that shape that I showed you on Apollo 11. But there's some other growth around here, there's growth under here, and here's something out here that is strange, is oddball formation. But that does purport to be the LEM. Okay, matters get worse here. Now this one, I think, should be the last one to correspond to the last get time. But this one is fully developed. And you see now, this octagon shape touches the ground. It's not high up like the octagon shape for Apollo 11. And they even have some sort of a crossbar that's black that is connecting this with that. And you can see it has a strange development of stuff that's sticking out here. And it has more of a structure of a little tree, you might say. Now this is the in-between one, which I think should be between the first one and the one I just showed you, because then that represents a progression of growth through there. And to have it go from something to fully developed and back to something halfway in between doesn't strike me as being correct. But nevertheless, that's the way they've got it. And you see this now is only about a foot, I would guess, above the lunar surface. But you can see more of the character of this thing. It's a funny looking structure. Okay, so I think the mission that had been planned for this was that they wanted us to know that they're capable of making a replica that looks like something we've got. And they are very smart on shading of light, and so you end up with things that look like elements that we know, and yet they are very strange. Okay, now if you can't read anything on this map, that's all right, because I couldn't either. What I want to do now is just simply to orient you geographic-wise. The center of the picture is the 0 meridian, and across here the equator. This thing is stretched out laterally to include 180 degrees clear over to this side and 180 degrees clear over to this side. So it packs everything in about Mars there. And now the Helenius Basin, right in here, and that is a marker for where we're going to take a look at another Mars photo. And if you realize that the opportunity is around the rover, is around the zero position on Mars, and the other one is like 180 degrees opposite. It would put it on the very edge of this picture. And so I wanted to get that concept of where you are, so that if the rover or Spirit were on Mars when the next picture was taken, they would have got inundated, particularly Spirit. Okay, now what you see here is a picture of Mars. It was shot from a distance of about 6.3 million miles. And can you bring up the light on that one a little bit? Yeah. Okay, so this is the North Pole, and the South Pole is down here somewhere. But you see, there's strange growth through here, and you begin to wonder just what that is. And so going on, now, yeah, there we go. Now what you see here is between these four arrows, there's an elliptical shape. Now that I marked as the nose. And it goes back, you can see that it goes back to here. And so I put a little dash mark as to the top line of the body. Now here's a rising streamer, and here's a lateral projection. And so what we got there, on the basis of what we know are characteristics of an EMV, we got an EMV right in that area. And all kinds of things. Once it's there, you have all kinds of things that happen. You know, you got this thing going up, and then it can give emissions, and anything down this way, it can give emissions, and so forth. And you can see that there's a lot of structure impacting here. And it looks like even that not all of Mars is there. Okay, so in lining up with respect to this picture, NASA says this is Hellas Basin, which is what I just showed you on that other map where it was located. And so now you're looking over to the right from Hellas Basin, and 180 degrees away would put you up in here, and that would be about where Spirit would be. And were Spirit there under these circumstances, it certainly would not have lasted very long. And so it's not too surprising to find that our rovers are in trouble. Now here's a photograph of the moon taken during the Apollo 13 mission. How do you like that? What is going on here is that there's an object up in here, and it's putting out some, well, this is sort of like a laser light streamer. And this is a big member that if you look closely up in here, you can see that it's connected to a body. And it goes down into here and puts out something you can see right in here that's pretty husky. And now what I found out in working this up, that when you have something like this adjacent to the moon, it is definitely affected. And there's a crossbar down here that's light. This thing comes, the projection from up top side comes down into here, and then there's an offshoot from there. And so this part of the moon is affected. So that you have a right angle area on the moon that is definitely affected by the presence of one of these EMVs. So you see, the moon is not a very hospitable place. It's actually hostile, and to be there, you're going to be exposed to some things I think that you don't want to be exposed to. Now, I put this in is to sort of make you realize, if you will, where we are. Over to the left is a Wright Flyer, and over to the right is a jet airplane, a symbolic airplane. These are kites, and I flew the kites, and I challenged myself to get them both up there side by side, and that's what happened here. And so we all know what the Wright Flyer looked like and its capabilities, and we know what a jet fighter can do, but we got something that is way, way beyond the jet fighter capability. Okay, now we're going to go into the concept of civilizations. There is a gent in the Soviet Union, and he's now in Russia, of course, and I believe it's the same one whose paper I read when I was doing foreign technology work. His name is Kardashev, Nikolai Kardashev. He proposed, what I saw in the paper, he originally proposed that societal IQ is proportional to the amount of energy that you can successfully manage. In other words, if you could manage nuclear power successfully, and you had been not doing that, you had stepped up to that, why your IQ just went up. And since that time, why there is a fellow, Kaku, a physicist, who locked onto some of on some of the work of Nikolai, and Nikolai has stated that okay, there's a type 1 situation of civilization, a type 2 civilization, and a type 3, and of course there's a type 0, and that's what we are. And so we're going to define this. Now, a type 1 situation is where a society can manage all the resources on Earth. And here's a picture of Earth, and you have storms and weather. You're supposed to manage all of that to be entitled to be called a class or a type 1 society. Now, if you're a type 2 society, then you've got to be able to show that you can manage all the resources of the sun. How do you like that? Now, that projection up at the top shows that it's a huge thing. I think I calculated like 80 diameters, something like that, Earth diameters. And it even looks like, in the way they've got it presented here, that there's a big object in here. So it'll be interesting to find that we have the sun made up of something else other than just a nuclear fusion pod. And that's my belief, and it's good that they've done this. It looks also like this might be an EMV in here. And it's got the underneath stuff. It's got a little circular area. This could be an overhead thing and also account for that wisp. So it looks like that the sun is not what we think it should be. And I am grateful for their color tuning of that to bring that element out. Okay, so now the sun is a situation where the type 2s manage all of that energy, okay? And then you go to type 3, and a type 3 civilization is supposed to be able to manage all the resources of a galaxy. And, you know, that's quite a jump. It's quite a step forward, but that's the way Nikolai Kardashev has defined this. And when you consider that the distance across a galaxy, then that's our galaxy, the Milky Way, 100,000 light years. Hey, that's a big area to travel in. How would you like to be managing something that was 100,000 years across? Its thickness is like 10,000 light years, and the thick part is like 30,000 light years. Okay, going on. Okay, here is my graph of what I call the physicist's playground. Now, down at the bottom here, what we've got, well, first let me explain the overall thing. I put into perspective type 1 situation, type 2, type 3, and give an indication of where Earth fits into this pattern. Okay, now you've got sort of the overall view. Now let's look at what the various things represent. Along the bottom of this is records all the visible energy that the universe provided, and that large number is here. And that energy was provided at the beginning of time. So this line is really the beginning of time. Okay. Now on the vertical axis, what you have is these types of civilizations. You see 0, 1, 2, 3, 4, etc. And if you can think also that those numbers are figures of merit or identifying numbers for the level of their IQ, it's all the same thing. It's that the civilization type is discrete. And it's discrete because they tie the energy that you're to control to those 3 different types of objects that I've told you about. And so those energies, like for Saturn, is right down here, and for the sun, it's right there. So Saturn and the sun are very close, and so Saturn really is justified in being a type 2, called a type 2. Okay, so Earth down here, is it a type 1? Well, no, not quite. We only manage energy that's at the 7/10 level. I would say we are about a 7/10 type of situation on this, to put graduate marks on that scale. Okay, so you go out to the Milky Way, and sure enough, the energy of that falls right there. So in checking the energy for these 3 points, they fell in a straight line in a plot like this. And that made me feel very happy, because when you have 3 points in a straight line, it makes it easy to extrapolate. And so I extrapolated primarily upward there. And the dashed line is the extrapolation, and it ends up on the beginning of timeline at about 6.5. So if you're to manage all the energy in the universe, you'd have to be a civilization of about 6.5 caliber. Now a question arose as to where God is in this picture. And the question arises, does he have infinite intelligence, or is it something less than infinity? Okay, so the curve is broken up here, and at the top there's infinity. I consider this top corner where the horizontal line that comes across and the beginning of time would intersect, that little intersection, I call that God's corner. Because it's infinite, he knows everything, and created the universe, which is essentially what that means. Time goes from right to left, and so over in here, the time would be about something in the neighborhood of 15 billion years. And so you can see that it takes quite a bit of time for these things to happen. Just the vertical separation between Earth and where we are now in terms of of producing energy, that represents quite a span of years. And so it also gives you some idea that, we're not going to get very far very fast unless we really wanted to do it. So now I want to try to give you a little flavor of physicists' thinking. And I got intrigued with Kaku's presentation. Now, it turns out that the starting point for Einstein's work was really the Pythagoras theory. And probably most of you know what that is. Namely, if you have a right triangle up here, you take the side here and make a square out of it. You call that area of that square based on that one side, plus the area based on the other side is equal to the hypotenuse, the long side of a triangle, the total area. So these two areas here of the opposite side equals the area of the hypotenuse. Okay, so you can just say that h squared then is equal to y squared and x squared plus. Okay, now the big point of that is only that it's two dimensions there. X and y are just two dimensions. And it's a planar kind of approach. Okay, so now how do you bring this up into 10 dimensions? And we'll show you how it's being done. Okay, here is a three-dimensional case. And so you do the same thing. You get X, Y, and Z for the difference. And you add those all together, and you get the length of that long line extending from one corner to the furthest opposite corner. And so that's the relationship that is there. Now, if you want to go to four dimensions like Einstein did, well, you simply throw in another term. And in this case, it was t squared. And so now he has four dimensions. He doesn't know whether physically or not it means anything, but he's got four dimensions. And so since he doesn't know what to call the resultant, he just calls it space-time, because you don't know what that resultant is all about. Now, if you want to go to 10 dimensions, I tried to make up a quick way to do that, but what it means is you have 10 terms, and each of them are squared terms, and you can substitute all other kinds of equations in each of the 10 terms, but you set it up so it's 10-dimensional, and that's what these physicists believe that they're doing now. I'd like to hark back to say that for the Type 2 civilization, Bob Dean tweaked me on that kind of situation, and I agree on his statement that there is in existence a Type 2 civilization. Maybe it's even a Type 3, according to what we saw there with the sun. So there is very great high intelligence kicking around in the universe. Now, it's a question of whether the physicists can come up with a theory of everything. Now, mind you, what has happened here is everything is based on the Pythagoras theorem. And the math guys like it because they get a plus and minus out of every square. So when you take the square root, it's either plus or minus. And so if you have energy, it can be either plus or minus. And so it makes a neat thing, but mind you, it's just geometry. Nothing more, just geometry. Okay, here are the things that the physicists are trying to do to plug their 10-dimensional theory. It's hard for me to read it. I don't know. Can you all see it? Yes. Okay. Yeah, space-time is the first one, and that's Einstein. So Einstein blocked himself out 4 right at the beginning. Now, the rest of them are what the physicists want to include to make up the 10. And you go down those and you come to quantum theory. That has given the physicists a lot of trouble because that essentially says that their systems are going to be digitized. The string theory, they believe they need something else to explain how things get started, and they're hoping that some sort of string will show up in the cosmos. Well, we got an EMV that is capable of making strings, so they have no problem that way. It's a question of whether they think it's appropriate to incorporate it. But right now, there's no realization as to why an EMV type of thing should be recognized. And the data are there. It's an open secret, but I guess the question of, well, I know it, but don't bother me with facts. Now, this thing is a little too high, but these are acknowledgments, and it's hard for me to read it.
You have 2 minutes.
Okay. All right, you can go through those and you see it. And all right, there are 3 women that are omitted from this, and I want to give them credit. One is my wife, who has spent a lot of lonesome hours while I've been trying to put a lot of this stuff together. Another is Judy Donnelly in Washington, D.C., who was my first president of the California Civil Engineers Society. And this was an education foundation, and she became president of the Education Foundation. And the third is Casey Dawkins, Marilyn Casey Dawkins, who has had a touch of her in most everything that I've presented. Okay, take-home thoughts. I hope you can read that. And we're running out of time. Okay, a closing thought by Stephen Hawking. He's claiming here that the ultimate would be if we can figure out something for everything, theory for everything, and that we'd know the mind of God. I think that's a little overstatement, but that's in the right direction. And here's my idea of where we are. We have a little rover here looking under Adirondack, but in the meantime, why, we got this huge EMV in the background with a laser pointing down to the surface. And I think that's about contrasts the technology. Okay, lights, we're all through.